Welcome to LabMIS.com and our lab video series on Cisco ISE 3.0. This is Mehta, your instructor for this video series. For a complete list of ISE videos, you can visit our website under the security section. There you can also sign up for our newsletters to receive the latest video update. In this video, we are going to be looking at two basic but very important topics of ISE, and they are certificate and node registration. ISE uses certificate extensively in almost every authentication scenarios, as well as internal communication to other ISE servers or to external system like pxCrit client or MDM servers. I can tell you already that having a proper certificate install is one of the keys to have a successful ISE deployment. The second topic is around node registration. It is very unlikely that you will only have one ISE server in production. So you might be looking at a deployment as small as 2 nodes or as many as to 40, 50 nodes supported by ISE. Either way, you will need to register additional ISE nodes at some point. So in our lab, we will show you how to build a typical 2-node deployment using a wildcard certificate. In our lab setup, we have 2 ISE VM server, ALM ISE1, which we plan to have that as our primary admin monitoring at the IP address of 172.1632.102. We also have ALM-ISE2 that we went through the installation a couple videos back, right, at the IP of .103. Right, we're going to use that to be our secondary admin monitoring. Both of our ISE servers are located on our server VLAN 32 that also has a Windows 2019 domain controller DNS server, and I'm going to use that as our certificate server to sign our certificate signing request later on. That server has the IP of 32.40. Everything is connected to switch number 1 right here. That's access our core switch and also provide access to the internet. The first topic we are going to look at is around certificate. Let me bring up the web access or web interface of our ALM-ISE1 right here. It's already been logged in. Anything related to ISE certificate, as you saw in the last video as we went through the entire ISE GUI, is located under Administration, System, and Certificates. Under System Certificate, by default, they are self-signed certificate used for various type of authentication and SAMU integration, as you can see right here. So you can locate them. You can look under the issue to and issue by, and if they're both identical, like this guy right here, ALM-ISE1, on both columns, that means it's a self-signed cert, and you can see it's even said right there, default self-signed server certificate, currently being used for EVE authentication, admin, which is our admin GUI right here, the portal, and Radius DTLS. Another one that you can see is for Samuel. It's a completely different cert, although it's still a self-signed. It has a Samuel prefix right there, and this one is a self-signed used for Samuel. The other 2 certificates that you see on the tops are purpose-built certs. One of them is for ISE messaging service, and the other one is for pxCrit, and they're both signed by ISE internal CA, and the way that you can tell, you can see that the issue by is different from the issue to. Right, the issue by, it's issued by the endpoint sub CA ALM ISE1 for both. Okay, so by this you can tell that it's being signed by ISE internal certificate authority, which we'll look at in the next video. But just FYI, these are the 4 default certificate that comes with the system and the fresh install. Let's click into the self-signed default one right here that's being used for authentication. Let's take a look. You can see subject alternative name. It will also populate the SAN field with that, with the ISE node FQDN. If you look at the usage, this is how you can change the certificate usage, and at least for this particular certificate, it's currently being used for admin, the EVE authentication, Radius TLS. We saw that the pxCrit and ISE messaging service used completely separate internal CA signed certificate, and then the Samuel has its own self-signed certificate, as you can see right there. Right, so, but these are all the usage that ISE needs. Down below, you have an option to enable certificate renewal. You can specify the period in number of days. And when the expiration comes up, the certificate will get renewed. Some of the things that you can do on this page, we already tried the edit. You can generate a self-signed certificate, so if there's a need for you to either do a manual renewal or create additional self-signed cert, you can do it right there. You can import a certificate, which you will do in a little bit, from an outside system. You can export a certificate. You can delete and then just a view. The menu down below is the trusted certificate, and this is the list of the trusted certificate that comes by default with ICE. The majority of these, as you can see, they are Cisco manufacturer cert. If you look at the name, but there are also some well-known third-party CA as well, such as DigiCert, as you can see right there. All right, there's one for VeriSign, for example. But if you use any other third-party CA that's not listed here and you need ICE to trust, then you're going to have to import that. One thing that's also recommended, if you scroll to the right-hand side, there's an expiration status column. Anything that is expired, which will be shown as a red X instead of the green check mark, should be deleted from the system. You should not keep any expired certificate. I guess it's also true for the system certificate as well. For the OCSP, if you want to connect to either internal or external OCSP services for certificate revocation check or status check, you can add it here by default. There's one that is checked against the ICE internal CA. That's why it's called internal OCSP. Otherwise, if you have an external OCSP, for example, on your enterprise CA or PKI, then you can provide the URL right there. You allow up to 2 for redundancy. You allow to cache the cert status if you want. You can clear the cache right there as well. If you need to generate certificate signing requests, here's the page to do it. And lastly, for certificate periodic check settings, you can perform revocation check on an ongoing client or endpoint active session for extra security. Right? Although you're going to make ICE work a little harder just because now it has to worry about checking the status of the certificate for your endpoints. And the bottom half of this page right here is for ICE internal CA, and we'll check that out in the next video. So when it comes to installing a certificate on ICE, you have 3 options. You have Identity Cert, a Wildcard Cert, or a UCC or SAN Cert. Right. With the Identity Cert, each ICE nodes will need its own certificate. So if you have 4 nodes deployment, then you will need 4 individual certificate. Using Identity Certificate might be more secure, but the more ICE nodes you have, right, the higher the management overhead and costs if you need to pay for third party to sign the Identity Cert for you. And this is where the wildcard certificate comes in. Basically, you only need 1 certificate for your entire ICE deployment, whether you have 1 node or 50 nodes, it doesn't matter. The wildcard cert also help with the better user experience when client does not need to trust a new cert when you do like a load balance or a PSN failover, for example, to occur, because there's some operating system like Apple iOS that kind of memorizes the cert. And if you all of a sudden switch it to a server that uses a different cert, the client might not be able to reconnect. So by using the same cert throughout your ICE nodes, you know that once the client trusts one cert on one server, it will trust all other servers automatically. Some organization may see wildcard cert as security risk because if the private key is compromised on the cert, then your entire domain behind that wildcard cert becomes vulnerable. So as a compromise, there's a third option, right, between the Identity Cert and wildcard cert, and that is known as UCC or SAN Cert. So UCC cert works in a similar manner to the wildcard, where a single cert can be used on multiple ICE nodes. Hence, it has the same benefit. The key difference here is that instead of using a single wildcard attributes in the SAN field, you need to make sure that all of the name of your ICE nodes and any URL that needs to support, especially on the various type of portals that you're going to have, are included in the SAN. The benefit for that, it helps limit where the cert can be used, which is good for security, but at the same time, if you need to add new ICE nodes with the new name or even the portal, or change the name of the portal and they're not defined in the cert already, you would need to regenerate the cert or have it re-signed, which can be cumbersome. If the certificate needs to be seen by public devices like guest access use cases, it is recommended to have it publicly signed so it can be universally trusted without you having to distribute it the signing CA cert. It is also perfectly fine to use the combination of publicly and privately signed cert. Maybe for anything that is customer or visitor client facing, you can use publicly signed, and everything else you can do your privately signed or sign with your own PKI. In this lab, we are going to use the wildcard cert, and it's going to be signed by our Microsoft root CA right here. So the first thing I'm going to do is to download our Microsoft root CA. Since the server we're using as a Jambox is the same as our CA, I'm just going to do a localhost /cert srv, download CA certificate, base 64, and then download CA certificate. Going to save that on the desktop, and we're going to call that guy root. You can take a look. Just so you know what we have, it is a self-signed lm-root CA. That's the name of our CA. Click OK. Then you want to go back to ICE. Under the trusted certificate, because ICE currently know nothing about our enterprise CA, we want it to trust our CA. So import. Select the file. Right there, root cert. Friendly name, we'll call it lm-root-ca. And we are planning to use this cert for authentication within ICE, for client authentication, cert-based admin authentication, as well as for Cisco services. Click Submit. The cert should appear right there, lm-root CA. Next, we are going to create a certificate signing request for our ICE. Under CSR, generate CSR. You can spend time reading this. It just explains the various usage for the certificate. Under the usage, because we're planning to use the same cert for multiple usage, we're going to leave it as multi-use. We want to do wildcard, so that's checkbox needs to be checked. There's something that you need to be aware of when it comes to wildcard cert on ICE. This is not a typical wildcard cert that has the wildcard in the common name, also called the star.domain.com type CN. ICE wildcard cert actually needs the wildcard in the SAN field, so make sure to communicate this correctly to your cert provider and that the provider supports this type of cert. There's also a security implication of using wildcard cert as mentioned earlier. So if you use your top domain in the wildcard, and the cert is compromised, then your entire domain is left exposed. A recommendation for this would be to create a subdomain just dedicated for ICE, something like ice.domain.com, which is what we have here. If you remember when we went through the installation of the VM, our domain was ice.labminutes.com, and I mentioned back then that there's a reason why we did that, and this is the reason, is to isolate the fault domain for ICE, right? And that's exactly what we are going to be doing here with the subdomain. And that way, any impact is contained within that subdomain. When you create ICE wildcard certificate in the CN, this could be pretty much anything. So it can be something like access.ice.labminutes.com. You could call it pretty much anything you want, right? As long as that same CN shows up in the SAN, which we'll do in a second. Let's go ahead and complete the rest of it. And again, just to stress, this is not a wildcard CN, as you can see. OU just said IT organization is Lab Minutes. City, San Jose, State, California, country, US. In the SAN, the very first one, you need to use DNS name, and basically you just copy and paste whatever you have in the CN that has to match and just paste it right here. And then you need to add the wildcard SAN as a DNS CN as well. And that would be star.ice.labminutes.com. For the key type, we're going to leave it as RSA 2048 with SHA-256. Go ahead and click Generate. Okay, there's a little warning saying the certificate contains non-resolvable CN access.is.latmius.com. Do you want to proceed? Yes. Click OK. Next, we need to get the content of the CSR. So you can click View, CSR content, copy that, jumped over to our Microsoft root CA, click Request Certificate, submit using base 64, paste the content of the CSR right there, and then we're going to use, this is very important as well as far as the cert template. Normally the web server is fine for the most part, again if you only use the Microsoft CA. Here we have a template called LM-pxscript created that we're going to use. And just FYI, this pxscript templates contains the client authentication key usage in addition to the server authentication, just in case we decide to use the same cert for pxscript in the future lab, right? That's just a requirement when it comes to pxscript authentication. You need both enhanced key usage of client authentication and server authentication in there, otherwise the authentication would fail. Or actually, you won't even be able to mark this cert to be used as a pxscript on ICE. Go ahead, click Submit. Base 64, download it. Let me rename to LM ICE 1. Save it. We can take a quick look, and you can see, just like how we specify in the CSR, the CN is access.ice.latmius.com, signed by LM root CA. And you should be doing the same thing as well when you get the certificate back from your cert provider, just to make sure that they didn't mistakenly sign this as a star dot. And then under the SAN, right here, you can see access ice.latmius.com and then star ice.latmius.com. Under EKU, like I mentioned earlier, you need both server and client if you want to use this for pxscript, right? Otherwise, the server authentication only would be fine. Once you get the cert back from your cert provider, then all we need to do is to bind that cert with the CSR, select the cert file, LM ICE right there, friendly name. Let's call this access dot, actually let me use a lowercase. Nope, it's actually access.ice.latmius.com, and let's mark this as wildcard. For these usage checkboxes, let's skip for now. We'll circle back and take care of this. But for now, let's go ahead and bind that certificate. As I said, validity period is longer than 398 days. Might be untouched by the browser. Click OK. All right, so at this point we have the cert installed, but not being used for anything, and we can go back and check under the system certificate. Right there, wildcard access ice.latmius.com, not being used.